Hello, I'm Deyao. Today I'll be presenting HalentNet, multimodal trajectory forecasting with hallucinative intent. Joint work with Mahmoud Zaram, Aaron Lee, and Mohamed Elsen. Our work focuses on trajectory prediction of the vehicles. Such a model is usually trained using trajectory dataset collected in the real world. However, due to the high complexity of the real traffic and interacting agents' combinatorial nature, it is hard to have a dataset that covers all the possible future modes. Therefore, to improve the multimodal prediction quality, our goal is to enhance the model by generating trajectories that are less explored in the dataset, while still encouraging plausible behavior. Let's start from how our model generates a normal trajectory. The generator of our model is a conditional VAE that takes map and historical information as input to predict the distribution of the future trajectory. The model is trained by maximizing the likelihood of a ground truth trajectory in the predicted distribution. In addition, we use a single discrete Latin code Z to model different driving intents, like turn left or overtake. The intent is inferred from the input data that is fixed when generating the future trajectory. Also, it is learned in an unsupervised way. To further improve the prediction quality and the distinction among different latent codes, we add a two-head discriminator that takes a trajectory together with an aligned map as input. The first head is used to judge whether a given trajectory is real or generated from a model as an unusual generative adversarial network. This head helps to improve the quality of the generated trajectories. In case the given trajectory is generated, the head 2 need to figure out which latent code Z generates this trajectory. This is done by classifying the trajectory into a latent code class. This head helps to widen the difference among different latent codes. So latent code can better model different driving intents. To further improve the prediction qualities and the distinction among different latent codes, we add a two-head discriminator that takes a trajectory together with an aligned map as input. To make sure that hallucinative trajectory looks plausible, it should be trained to have a high real fake score judged by the discriminator. Also, to make sure that hallucinative trajectory is different from a normal one, it should be hard to classify into any single intent. Our model is trained simultaneously using both the single intent and the mixed intent. When we train with a single intent to generate normal trajectories, the generator is trained to maximize the likelihood of a ground truth future, to increase the real fake score from the discriminator, and to reduce latent code classification loss. The discriminator is trained to judge whether the given trajectories is real or generated, and classify the generated one into the latent code it comes from. When we train with the mixed intent, the generator is trained to increase the real fake score of the hallucinative trajectories, and to make hallucinative trajectories hard to be classified by increasing the entropy of the classification distribution. Note that the discriminator is not trained here. Our method achieves the best performance compared to other state-of-the-art approaches measured by the FD1 score or nuisance. For detailed comparison, we obtain about 27% improvement on average FDE over the output distribution, and 52% of our road boundary violation improvement over the baseline model we based on in the 6-second prediction case. Human evaluation on Amazon Mechanical Turk shows that our method generates better trajectories compared to our base model measured by 40% more votes. Qualitative results show that our method reduces the uncertainty of the future by a large margin and also increase accuracy. Thank you.